A system of equation can either have no solutions, one solution, or an infinite number of solutions. That would be determined by the equations themselves. Two distinct equations would make one solution. They would intersect each other once. Two equations that have the same slope would result in parallel lines, so there would be no solutions at all. And then two equations that end up being the exact same equation would have an infinite number of solutions because each line overlaps the other, so every point is a solution. In this question, they want us to determine how many solutions there are without actually graphing any of the equations. So we're going to do that by looking at the equations in the form y equals mx plus b. So what I have to do is take each equation and isolate the y. So I'm going to move the 3x over, and then I'm going to divide everything by 5. So there's my first equation. My second equation was already in the form y equals mx plus b, so y equals negative 3/5 x. There's no y-intercept here, so it just stops there. What I notice right away is that my slope is the same. Each equation has the same slope. That means these are two parallel lines. In other words, or therefore, there are no solutions. The two graphs will never cross each other. They're two lines that run parallel to each other for infinity. They don't cross each other. Let's look at the second example. So isolate your y. So I'm going to move the x over, and I'm going to move the 8 over, and then divide everything by negative 4. So y equals 1/4 x plus 2. And compare that to my second equation, which actually was y equals 1/4 x plus 2. So both of my equations are identical. So if I were to graph these, I would get one graph right on top of the other. So in that case, I would have an infinite number of solutions. Since they touch each other at every point is considered a solution. So that system of equation has an infinite number of solutions. Let's look at this last one and see what will happen there. Oh, negative 7x plus 12, and my second equation Okay, so finally, when I look at these, it looks like I have two distinct equations. That means they'll only intersect each other one time. So these are crossing lines. One intersection, that means one solution.